Okay, so first question here is the integral from 1 to 3, 3x squared minus 4x dx.
Okay, so you just do the derivative of the 3x squared minus 4x and then plug in the points.
Yeah,
Oh,
antiderivative.
sorry, yeah, that's what I meant to say.
Yep.
3x to the third over 3 minus 4x squared. 2. That cancels out. 1, 2. X cubed minus 2 squared. 1 and 3 cubed. 3 squared minus 1. Seven. 18. 10.
Yeah, that's 9 plus 1 looks like it's 10.
Cool.
So the next problem, do you want another one like this?
No, I think that's
Okay.
fine.
Okay, so next problem is they give you f of x, they tell you it's x square root 4x minus 1, and they just want you to find f prime of x.
Okay, so you just make the 4x minus 1 to the 1/2.
Yes, you do have to rewrite this to be able to correctly find the derivative. It is a product rule, but the second thing, the v, if you will, is a chain rule.
Okay, so first, when would it be when there's a square root and it's a negative 1/2? Is that if that's if the square root's on the bottom, like on the denominator?
Yes.
Okay.
Yes.
X times 1/2.
This one's important that you simplify. And I think it could be, it's a little bit more than what is here. So I'm not sure how far you've gotten, but I'd like to jump in here.
I got to that step. I just don't really know what to do from here.
Okay, so the 1/2 and the 4 go together. That's 2x over, and this is what you were asking me about earlier. It's the square root of 4x minus 1 plus this becomes the square root of 4x minus 1 like this.
What about the x on the first?
Yeah, it's there. It's x.
Oh, I see.
Okay. If you were to look at the answers, which I really don't want you to do, you'll see that it's only one term. So they somehow combine this. And that's where I think, it's not really even a calculus thing. It's just do you remember how to combine this? And maybe you just need a gentle reminder that you would multiply the top and bottom over here by square root of 4x minus 1.
Oh, okay.
And the reason you would do that is because you do want the same bottom, even if it's not appealing like this one is. Now, with the top, the square roots cancel and you just get 4x minus 1.
Uh-huh.
and then you can combine the numerators.
Oh,
So you get
got it.
6x minus 1, because I mean, you're not taking, the AP's long gone, but like, that's probably what students were like, oh, I forgot how to do this. And they could do the calculus, they just couldn't do the combining of stuff.
I thought you can't have a square root on the bottom, though.
That's true. That's true. So this is also wrong from a like aesthetic standpoint, but the answers are all presented this way. So you would leave it. That's like a preference, a math preference. It's not really like a, I don't know, it's not a commandment of math.
Got it.
Okay, do you want another one like this? Is that good? What do you say?
We can go to the next one.
Okay, so the next one says if the integral from a to b g of x dx, so it's symbolic, is 4a plus b. It's like saying, okay, the area from these two things is 4a plus b, just so happens to be the bounds, great. And the next, so that then they're saying, well, what is the integral from a to b of now g of x plus 7 dx? And this problem is asking you to remember how to break apart integrals.
Okay.
So it's the integral g of x dx plus 7 integral a to b dx. Because you can bring the 7 is inside here, but you can bring it out because it's a constant.
Oh yeah, okay.
And that's kind of like, okay, well, so now what? Well, we already know this one. This one is 4a plus b. That's given.
Uh-huh.
But what about this one on the right? Well, what is the antiderivative of dx?
Okay. Yeah.
Just x. And you evaluate it from a to b.
Oh, this is weird. Okay.
Yeah, and if you don't like that, I mean, that it's just top minus bottom.
Oh, you distribute the 7?
Yes.
And then you have to combine. So
Minus 3a plus 8b, or 8b minus 3a.
Okay.
The answer is actually presented this way, which is another kind of preference to put the positive one first.
Right. Okay. Cool.
Do you want to do another one like this?
Yeah, let's do one more like that.
Okay, let me make it slightly different. Let's say the integral from 0 to b f of x equals 4b squared. What is integral 0 to b, there's a dx there, f of x plus 2x dx?
Okay. So 0 to be f of x plus So when you break up the 2x, it becomes like 2 integral 0 to b x, right?
I was trying to help you out here. It's integral 0 to b 2x dx.
Oh, this is different. Okay.
It's slightly different. I mean, it's maybe easier in some ways.
Well, so then you just do the antiderivative of 2x?
Yep. Yep.
Okay.
X squared
So
0 to
the
b.
last one, with the 7, did we?
It was just dx. There was no x.
I see. Okay.
Yeah.
So, okay, so then this becomes 0 to b 2x dx. B squared. So 5b squared?
Yes.
Okay.
Okay. Yep. Here's another good one for us to look at. This actually, I think it's better if I type these, write these. Okay, so it says if f of x equals minus x to the 5th plus x plus 1 over x squared, they're asking for f prime of -1.
Oh, okay.
So they give you the function. You have to be able to take a derivative and evaluate the derivative at a point.
Okay, so x plus, I see, squared. And then find f of- So -5.
You may want to rewrite the original
Oh, okay.
if it helps. Depends if you can visually see this without writing it, then you don't have to take the time to do it. But
-2x to the negative. And then if it's a negative exponent, you like add 1 basically, right?
you always subtract. Well, no, you subtract 1 for derivatives, and that's maybe a note card to really get that derivatives.
Yeah, I subtracted it on the 5, but the -2, yeah, so it'd be -3, right?
Yes, I mean you're adding the number but keeping it negative.
Yeah. Oh, I don't know why I said that. Okay, never mind.
Well, you sorry, you likely knew what to say, or what you
Yeah,
likely
I
knew what
wrote
to write.
negative. I knew -3. Wrote
Yeah. And that's one of the limiting things of what way we're doing it. This format is I don't see what you're writing. But yeah, if this is what you got, this is correct.
Yeah, and then you plug in the -1.
Yes. Now I would probably rewrite it before I evaluated it, or as I evaluated it, I would rewrite it so that I put the -1 in the right spot and didn't misinterpret what it means.
Okay. So -5 times -1 to the 4th plus 1 minus 2 over -1 cubed. And then that's -1 to the 4th is 1. So -5 plus 1 minus 2 over -4 minus plus 2, -2.
Yes. Yep. All right, so the next problem is kind of like this one. Can you first take 2 derivatives of this, and then I'll get the question in there.
Okay. Wait, take 2
Yeah,
derivatives.
I'm sorry, it's just y. Yes, take a first derivative and then a second derivative, please.
Okay, got it. So it's 20x. 72x. Okay, so the first derivative is 20x cubed minus 72x squared plus 48x.
Okay, and the second derivative?
60x squared minus 144x plus 48.
All right, very good. So the question asks about concavity, so you have to set this equal to 0. And factoring something this large could be quite hectic. Sometimes you just look at the smaller numbers and see like, well, what goes into both 60 and 48? Hopefully you give me a number bigger than 2. 12 is a good choice. So let's start with 12. 12 gets you 5x squared minus 12x plus 4. And does this one factor? Well, according to the answers are nice. So yeah, let's assume it does. So I would use a guess and check approach here because there's only one factor. Yeah, so it's -2 and -2.
12x, okay.
So your two critical, well, your two possible inflection points. These are possible, not necessarily. Is yeah, 2 and 2/5.
Mhm.
So the next step is to draw a number line and put those two critical points or inflection points, they're not critical points, on the number line. And you want to test something in each region.
And do you test that back in the original or the second?
I like the factored form because you're only looking for whether it's positive or negative.
Okay.
But I also mentioned this, and I wish I could convince students like yourself because it really is help. This is a quadratic that opens up and it has this shape. And that tells you where it's positive. It's positive here, it's negative here, and it's positive here. Now we're going to verify that in a moment, but that's the shortcut to figuring out the sign chart.
Well, how do you know it's a quadratic?
I'm just looking at just x squared. I'm just looking at that.
Oh, I see. Okay.
Yeah. So let's test 0 though. 5 times 0 minus 2 is a -2. 0 minus 2 is -2. Negative times a negative makes a positive. Times a positive is a positive. Confirmed. So something between 2/5 and 2 would be like 1. 5 times 1 minus 2 is 3. It's positive. 1 minus 2 is -1. Positive, positive, negative gives you negative. Similarly with 3, 5 times 3 minus 2 is 13. Positive. 3 minus 2 is positive. 1. Positive times positive times positive. It's confirmed.
Got it. Okay.
So now we still haven't answered it. These are a lot of work. Where is it concave up? So wherever you see the plus.
Increasing?
Yeah, so wherever it's positive. So up from 2 to infinity. Now they actually don't always use interval notation. So their answer is actually x less than 2/5, comma x greater than 2.
Okay.
It's down
2/5.
2/5 to 2, but their answers are in this interval notation. So 2/5 less than x less than 2.
Okay.
Please study this example. I think we did one yesterday like this. They're almost for sure going to come up in some form, you know, taking the second derivative, set it equal to 0. Kind of thing. All right, 6 here. Actually, let me give you one. I can make another one up if you want. So 1/3 integral e to the t over 3 dt. And this is it. There actually is no instructions. That just says, what does this equal? So a couple ways to do this. Like the first way is to use a u substitution. The second is to use kind of a specific antiderivative.
I showed you yesterday, I think.
Yes. It's the integral e to the u du is e to the u over u prime.
Okay, so then that would be.
But that only applies to this part. The 1/3, comes along with it.
So it would be e to the t over 3 over.
What's the derivative of t over 3? Or maybe it's 1/3 t is a better way to write it.
1/3.
Just 1/3.
And then times the 1/3 as well. So then the 1/3s cancel?
Yep. Plus c.
Okay.
So like, let's try another one. So maybe just a minor variation on that. Let's go 1/2 integral e to the 2t dt.
So e 2t over 2 times 1 e to the 2t over 4 plus c.
Yeah, so it ends up being 1/4 or over 4 plus c. Yeah, good.
Well,
All right, so I'd like this next problem, but I do think it should be, I'm gonna just slightly modify how it's written. It says d dx. This is how I think it actually should be written. Cosine cubed x squared. So the way it's written though is it's written this way: d dx cosine cubed x squared, which is correct, but it's like, this is very clear. You're taking the derivative of everything to the right. So you're taking the derivative of this part that's inside parentheses, and this x squared is the argument of cosine.
what do you? I'm confused.
Okay, so let me further rewrite it. It's cosine of x squared to the power of 3. And you're taking the derivative of this thing.
Okay.
But you're supposed to infer all that from this. And I don't know if that's reasonable or not.
Okay.
But the derivative here, you have to, it's a chain rule. You have to power rule,
So
cosine, and then inside.
So it's 3, and then power, or no, power rule first, you said.
Yeah.
Cosine x squared, and then the chain rule part. So sine x.
Is it sine or minus sine?
Minus sine x squared, and then times 2x.
Yes. Now, the answer would not be presented this way on multiple choice. So let's decode it a little bit here. The negative and the 3 and the 2x go together, so it'd be negative 6x. This 2 would actually be here. So it'd be cosine squared x squared, and then sine x squared, like that.
Okay. It's a lot of rewriting.
Yes. So let me give you one like this. D dx of sine 4th x cubed.
So it'd be sine, or no. Four times sine. Oh wait, I'm not done yet. I still have 5.
Yeah, there's a lot here. Take the time you need to.
So wait, sorry. Can you multiply 3x and 4?
You do, but did you take the full derivative? Like, did you?
Yeah.
Okay. Yes. The answer is yes.
Okay. And then that's 12x sine x cubed cubed cosine x cubed.
Right. There's other problems like this. Like let me show you. Let me show you. We don't have to do this, but go ahead.
Sine x.
Sorry.
Oh, I forgot the squared here. Okay, wait. That's sine x squared. Okay, yeah, I just forgot one squared.
So another type of problem you might see, which is a little weird, is they could go natural log fourth of cosine e to the x d dx. And so what this means is it's really the natural log of cosine e to the x all to the power of 4.
Okay.
I don't think you're going to see this, but that's like another possibility.
Got it. Okay.
Because I mean, it's they're very consistent with how what they emphasize in these exams.
So basically, just bring the.
It's just like last one. You start with the power rule, and see, it's not to be confused with the following, which is natural log cosine e to the x to the power of 4. This one is, and there's it's a small difference, but it's significant. So I probably shouldn't even have brought it up. Overthinking over here.
Okay.
Does seeing these sort of the strange examples help, or does it distract?
The side one?
Yeah, like seeing some obscure thing that Matthew thinks, well, it might happen 1% of the time.
Maybe the one on the left, but the one on the right, I guess not.
Okay. All right. I want you to read this question and tell me what this is the graph of, and there's really two answers. It's the function or the derivative that I'm looking for. If you're not sure, I'll tell you, but this is a key part of answering questions like this.
Wait, like what the graph is of?
Yeah, is it the graph of the original function, or is it the graph of the derivative of the original function?
I could not. I don't know.
So see where it says velocity?
Uh-huh.
That means it's derivative, and it's really important. This is not the graph of the original function. You're not. This means something different when it's above the x-axis.
Okay.
So like what this means is its velocity is 0, its velocity is 1, its velocity is 2, its velocity is 3, its velocity went down to 0. Then its velocity went to -1, stayed at -1, stayed at -1, went to 0.
I see. Okay.
So v equals 0 means it's not moving. V greater than 0 means it's moving forward. V less than 0 means it's moving backward.
So if it was just the function, what would it say?
They don't generally, but it would say like position X or S. They'd tell you the position.
I see.
Okay, so now we can answer some of the questions. So let me just grab this graph. Actually, let me just snip the graph and then the question each time. That'll help with this. So there's the graph again. And question number 1 says, what value does the spider change direction? Change direction. So changing direction means it's going, it went from being forward to backwards.
Forwards to back.
So all what I'm tracing right here is forwards, and this is also forwards. But right there, it stops moving.
Right.
And then it moves backwards.
4.
Now here it does not change direction. It just stops moving. If it were to if it were to come up, then it would change direction, but that is not what's happening.
Okay. So anywhere it crosses the x-axis.
Yes. Has to cross, not touch, like you just said. It's critical. All right. What is the total distance the spider traveled? So this is that whole distance displacement thing. Total distance means you count positive areas positive and negative areas also positive. So areas above the x-axis are generally positive. Areas below the x-axis are generally negative. But when you're finding the total distance, you treat those negative areas as positives. So you have to find the area of each of these regions.
Okay, so you have to split it, yeah.
Yeah, maybe 1 and 2. This is a trapezoid, if you remember that, or you can combine, you know, this triangle over here with this one over here. Lots of options.
So 4.5 plus 1.5.
Yeah, and then
6.
So maybe 9.
Yeah. The 3 comes from where?
I'm moving this triangle over here to make it kind of size up better with this rectangle. You play any of those games on phones where you move shapes around?
Okay. So then you just wait. That's 1, 2, 3. Oh, 3 times 1. Okay, got it.
Yes. Okay, now perhaps the most difficult question, but we might as well try and tackle it. It is a useful thing that you would see on these tests. An equation of the tangent line. So again, this whole graph right here, it's a graph of slope.
Yeah.
Okay, but just trying to get you to buy into that. Oh, I'm sorry. This is unrelated. I'm sorry. Now I see why this is weird. Okay. I was like, wow, that's gonna be a really hard problem. All right, never mind. Okay, this is the question. It says, actually, let me, no, we'll just do this. Okay, so you have to be able to take a derivative of this function on the right. Can you do that for me, please?
Yes. So that's negative sine of 3x. No. There's a 3x. No, it's a power chain rule, right? So 3. Negative sine 3x times 3.
Yes. Okay, now tangent lines. So what do you need for a tangent line? You need, the first thing you need is a point. And the second thing you need is a slope. So the point comes from taking this x value and putting it into the equation.
In the original equation or in the?
Yeah, in the original. The slope comes from taking this point and putting it in here.
Okay, so cosine 3 times pi over 6, basically.
Yeah, so what is cosine of 3 pi over 6 or cosine of 1/2? So that's on your unit circle. That's up here.
Well, why would it be 1? Wouldn't it be 1/2 pi?
Yes, which is pi over 2, 90 degrees.
Oh yeah, okay. It is, that's 1.
The sine would be 1, but the
Zero.
x, so yeah, 0. So that's your That's your point.
Got it. Okay.
Okay.
And
Then you similarly you put over your minus sign. 3 times pi over 6 times 3.
so that one is
That
1.
one's 1, but it's negative, so it's negative 3. And that's your slope. So the most common form of the tangent line is this one.
Uh-huh.
And you just plug in your given information. So y minus 0 equals minus 3 times x minus pi over 6.
Cool. Wait, wouldn't that one be the sine? Okay, so sine 3 pi 6, that turns into pi over 2. Oh, I see. Okay. Never mind.
Do you want another one like this?
Sure.
Okay. All right, so y equals 2 sine just trying to think of something here. 3x. No. Let's do cosine again. And let's do x equals pi over 2.
Cosine. Okay.
So we want the tangent line of this.
But then that's 2 negative sine 3x 3. 3 pi over 2, is that the bottom one?
It is.
Okay. So sine of that is negative 1. But then that's also negative. And then 0. Okay, so it's y1 equals then so is y, never mind, to figure it out, 6.
Do you have a slope?
Slope is is that the one that you plugged into the derivative?
Yes. Yes, you have to put the x value into the derivative. Yep.
6.
It is 6. Good. So it's y minus y1 equals slope x minus x1. Y minus 0 equals 6, x minus pi over 2.
Yeah, I got that.
Fantastic. All right. Oops, that was not good. There it is. Okay. Let's go to another question. A lot of pictures. Okay. I'm gonna snip this one in, but we'll work it out together. It's one of these obscure questions that probably would be challenging without seeing it, something like this first. So it says, at what point in the graph of y equals 1/2 x squared minus 3/2 is the tangent line parallel to the line 4x minus 8y equals 5? So parallel is really important here. Parallel means same slope. So we need to find the slope of this, and we need to find the slope of this.
So derivative again?
Derivative of that one, yes. The derivative is x, just x. How do you get the slope of this? This is not calculus.
So you have to move, like rearrange it.
Yes, solve for y.
Y equals 5 minus 4x divided by 8. Y equals 5 minus 4x over -8.
So slope is 1/2.
Yeah.
So this is the slope of the 1 equation, and x is, so x, this is the slope of the line. And so this is the equation of the slope. So for what x value does this equal 1/2? Well, it's when x is 1/2.
Yeah.
So now if you were to look at the answers, you would see that there are actually two answers that have 1/2. You don't need to look, but to get the y value, because it says tangent, that means the 1/2 has to go back in here into the original.
Oh, okay. So it's
And
1/2. Yeah.
we should do this just because it's
So then that's
clear problem. Yeah,
1/4.
1/4.
Yeah. So
So
1/8.
1/8, and then this becomes 12/8.
Negative.
Yeah.
Okay. A little odd.
Yes. And this is no calculator, all of this?
Yeah. I have a whole calculator section too, but I didn't send that.
Okay, yeah, the next one I'm looking at, I without a graph, it's very challenging. Okay, let's do 16. It says the region enclosed by the graph y equals x squared plus 2 and y equals 11. So whenever it says region enclosed, you're supposed to think area.
Under the graph.
Area means integral in calculus.
So you take the integral of x squared plus 2.
Well, real quick, a brief sketch of this. We know that x squared plus 2 is something like this, and y equals 11 is something like this.
Uh-huh.
So we're trying to find this region right here. If we write integral, what do we need below it and above it? The bounds.
Yeah.
And how do we get those? From setting these equal to each other.
Oh. Okay. So x squared plus 2 equals 11. X squared equals 9. X equals plus minus 3.
Yes, so there's your bounds. The area is always top minus bottom. So for you, that's 11 minus parentheses x squared plus 2.
Okay. -3. So you do the antiderivative of that. So
Yeah, and I'd probably like clean this up a little bit. I would write this as 9 minus x squared and then do the antiderivative of that.
okay, 9 minus squared. So then that's 9x minus x cubed over 3 from -3 to 3. And that's 9 times 3 minus 3 cubed. 3. times 3, 27 minus 27 over 3. Um, 36.
That's wrong. It's 18. Yeah, 18.
I got 36.
Yeah, 36. I miswrote some here. Yep.
Okay.
We can do another one like that if you want, or if it's clear. We actually, we're actually not, we don't have enough time for that. They'll maybe find another problem that we can do. Yeah, let's do this one. This is another, we haven't covered this concept today. Okay, so it says the average value, and this is like one of those things where it's like, wait, average value, you know, it doesn't even seem like a calculus thing. Average value refers to the following: integral f of x, a to b, 1 over b minus a dx.
Okay, so like your a in this case is -2.
That's right.
Okay. And then
So
1 over 6. And then that's cosine
becomes cosine.
x. So then cosine of 4. Or do you just combine those because you can't do it without a
Well, you actually can't combine them, but there is a little wrinkle here. The cosine of minus x equals the cosine of x. So the answer, the way it's presented in the answer sheet, is actually cosine of 2. Like this. Yeah. So just like the other one that you might need is that sine of minus x equals minus sine of x.
Okay.
Yeah. I think the older exams in this, I mean, I don't know where this is from, but I'll just say generally they tended to emphasize more of the trig that you may or may not have like really thought much about.
Yeah.
In the last little bit.
Like 2 years.
Yeah, exactly.
Right.
But that's you know, the kind of thing that you might see. So we did not get through a ton of this. So we can pick up here where we left off or whatever.
Yeah, I have a few more scheduled, and then on Monday this coming week he'll give us the take-home portion, and that's due on Wednesday. So
sounds good. All right. Well, I look forward to helping you, and I'll send you the notes here shortly.
all right, thank you.
Have a great day. Bye now.
Bye.